Beyond Clean offers a creative look into the inner workings of a healthcare industry committed to getting it right every instrument, every time. Join us every week as we explore the hidden world of one of the most important aspects of safe surgical care. And now your hosts, Hank Balch, Michael Matthews, and Justin Poulin.
This week on Beyond Clean, we speak with Steve Kubler, Global Marketing Manager at 3M. Steve has worked in healthcare for over a decade, helping to bring advanced solutions to the sterile processing department. He started out as a sales rep for 3M, working with hospitals and large surgery centers on the East Coast, which fueled his passion for the SPD and the teams that work within them. He later transitioned to a clinical expert role in 3M, overseeing biomedical, electrode, and sterilization monitoring solutions. Steve is currently the U.S. Marketing Manager of 3M's Device Reprocessing Division, and we're going to bring him on today, Hank, to talk about biological indicators and how they work, and a phrase that Mike likes to take credit for coining, the biological speed wars.
That's right, Justin. And I'll tell you, in consulting across the country with facilities that are preparing for the Joint Commission surveys, a lot of folks are stressed out about how their documentation looks for their BI test. And even, the overall understanding, what is this thing and why are we doing it? Typically department leaders have a good grasp of that. Oftentimes the specialists do, but especially for folks who are newer to the industry, they may not know the name of the spore that's used to test their steam sterilizers or why we do it this way in the U.S. and it may be done differently overseas. I'm excited to get an expert on the show today, to kind of go into those categories and shed some light on the reoccurring questions in the field.
All right, well, before we get started, a reminder, you can subscribe to Beyond Clean on iTunes, Stitcher, Google Play, and Spotify, or search for Beyond Clean on your favorite podcast application. We can also be heard on the Sterile Education app, which is available on iTunes and Android. Follow Beyond Clean on Twitter at Beyond Clean Info, Facebook.com/Beyond Clean Podcast, LinkedIn.com/company/Beyond Clean. Our Instagram page is Beyond Clean Podcast. If you have a future topic or guest that you'd like to recommend for the show, or if you'd like to share a picture anonymously on our Instagram page, send an email to info@beyondclean.net. Finally, check out our new and improved website, beyondclean.net. That's where you will find the quizzes for our Season 2 episodes and earn CE credits for listening to these shows. Season 2 CE credits are brought to you by our sponsors, Innovative Sterilization Technologies and Petrus. The One Tray system. Are you tired of playing catch up? Now you can process your vendor trays and other high-turn hospital-owned surgical assets in a fraction of the time it takes with sterilization wraps and other rigid containers. Maintain one standard of care, eliminate wet and torn wraps, and save your facility money. Efficient, safe, storable, durable, and secure. Invest in the best, the One Tray system by Innovative Sterilization Technologies. And Petrus is an advanced sterilization intelligence company built to maximize the management of manufacturers' IFUs, drive regulatory compliance, and deliver quality products safely to the patient. The Bluefin software utilizes algorithms and complex systems designed to combat common daily errors being performed in sterilization departments across the country and around the globe. For more information, visit PetrusInc.com. That's PetrusInc.com. We'll be right back with Steve Kubler. Beyond Clean. Joining us now is Steve Kubler, U.S. Marketing Manager of 3M's Device Reprocessing Division. So, Steve, let me welcome you to this episode of Beyond Clean. We're excited to talk to you today about biological testing and sterile processing.
Thanks, guys. I am more than thrilled to be with you guys, and I can't wait to dive into some of these questions.
Why don't we start by talking about how biological indicators actually work? I'm not sure everybody on the front line knows how to use them, but maybe they don't understand exactly how they work. So let's start there.
Good question. Believe it or not, one question that we get pretty frequently, and I've heard of everything where it just works to that are spores in there, which would actually be the correct answer. A biological really is designed to test the lethality of a sterilization cycle. And in order to test lethality, the only thing that does that is you have to actually measure kill. The sterilization, the definition of sterilization is the absence of all life. And so to actually measure kill and to actually prove that you have performed or that the sterilizer has produced a sterile or sterile conditions, it has to kill an organism. And the organism that we use in biological indicators, in steam biological indicators, is Geobacillus stereothymophilis spores. The reason we use those spores is as you guys probably know, not everyone, especially if you're new to the field, truly knows why we use the spore. We use the spore because we know that it's highly, highly resistant. It's one of the most resistant spores that we know of to temperature and to bad conditions, to poor conditions. So that the rationale behind it is if we can kill that spore, if we can kill Geobacillus stereothymophilis spores, then we can kill lesser spores that are way easier to kill. Like anything that would be remaining on an instrument after the manual cleaning process occurs. Biological indicators, they have a couple different components in it. First and foremost, typically they'll have a cap. They have a container which holds the spores. They have a growth media ampule, which typically that growth media ampule is in the biological indicator as food. And so what will happen is once you run a cycle, you pull that biological indicator or BI out of the chamber. You wait for it to cool typically. You'd crush it. So typically there's a glass ampule in a biological. That media will hit the spore strip, wherever the spore strip is located. And if there are spores still living, you'll have a reaction. So the spores will eat it. They'll secrete their waste. And then what happens is with rapid products, it actually secretes a bioluminescence, which is what an order reader reads. And then with a typical standard product, you get a pH color change, which occurs over time within the biological indicator. And as you guys know, positives are, I don't want to say they're a bad thing because they're a good thing, right? You don't want to pushing through a cycle or a load that didn't pass, but sometimes they cause some headaches. If they come back positive, you got to break down and start the process of reprocessing that load. But BIs, as you guys are aware of, there are standards around BIs and why we use them and why we're testing for lethality. And so BIs should be used weekly, preferably daily, but within every implant load that's run. And the reason for the implant loads is because they're so critical. Sometimes they're going into deep tissue. You want to make sure that the conditions were met for sterilization before that can be used. If I could equate it to anything really, guys, it's just like a carbon monoxide detector. It'll go all day, all night. As soon as it detects a problem, it alerts you, which is what a BI is meant to do. It's meant to notify you when there's a problem, when the conditions aren't ideal for sterilization to occur.
Hey, Steve, the BI market was, pretty stable there for a while. And then all of a sudden it was like BI wars started. And, I think 3M kind of fired the first shot when they took the BI down from 3 hours to 1 hour. And so now there's just been a lot of competition in that market. And so I think a lot of our listeners are probably sitting there wondering, are all BI tests created equal? Are they the same? Does it just matter which one is cheaper? Or what are we really getting?
Good question. There's been a lot of change. And so I think the short answer is no, all BIs aren't equal, and that there are multiple BI types for the different purposes and processes that you guys have. A couple things when considering a BI is there are a couple key things that you want to consider when choosing a BI. So you want to consider your facility's workflow. Ideally, does the BI, is it something that you use? Is the process easy to utilize that BI? Is it also easy for your staff to understand and utilize and activate? Another pillar that you want to consider when looking at BIs is the BI a quality product? Resistance is critical. So is it too easy to kill? And if it is too easy to kill, is it really truly giving you a true result of what's happening inside the chamber? Does it perform? Or does it experience consistent performance breakdowns like a growth media leakage or other potential issues with the design of the product? And then again, as you pointed out, there are multiple different types of speeds on the market. And so finding the right speed that works for your facility is critical. As you guys know, 3M has recently come out with a 24-minute product, which getting faster means that the product that the Central Sterile teams are doing out of Central Sterile is a better product. It means less wait time. It means less early release forms. As you guys know, getting docs to sign off on that is not easy. So less wait times. Moving to ELM, every load monitoring, as I said before, the standard is weekly, preferably daily, but with every implant load. Why would you run a BI with every implant load, but not for non-implant loads? Are you giving the customer or the patient the same standard of care? The answer truly, if you really dig down into it, is no. If you're proving sterility with a BI for one load but not another, it's technically not exactly the same standard of care that you're providing for the patients. Getting things faster, is critical, and it could help you to accelerate your practice and your performance as an SPD, as a member of a healthcare facility. And the latest technologies enables SPDs to test both steam and hydrogen peroxide BIs in one order reader, which really takes the process and the thought process. It streamlines process and takes the thought process out of which BI goes in which order reader or which BI goes into which modality. They're color-coded, they go into one reader, and it really looks to optimize the process to make the department faster.
So, Steve, I want to follow up on your standard of care comment with every load monitoring. And, as a global podcast, we hear and are aware of the different testing protocols and regulatory standards across the globe. And obviously, depending on where you are in sterile processing, your standard of care, even by a regulatory standard, is different. I know in Europe, there's not as tight a standard as it relates to biological indicator testing, and they're much more accepting of the parametric release or tracking instead of BIs. Can you talk to, considering what you said about, wanting to make sure the standard of care is the same from every load monitoring as opposed to just weekly monitoring or just with implants, but what does that conversation look like globally when we say, well, in Europe, they're not using biological indicators at all in the same way that we are?
I think directly comparing parametric release versus BIs is a little unfair, and the reason I say that is because you need both. And I truly mean that. Being out in the field, with experience in healthcare, BIs have a place, and so does parametric release. Releasing on parameters and that early indication of, is everything working in my sterilizer right, I think is critical. But I also think that, like anything else, there needs to be a checks and balances, and that BI is truly, again, like I said earlier, is truly the only way to measure lethality. And so there's recently a published paper from Dr. Yost, and what it found was that 1 to 2% of cycles fail no matter what. And the paper the data was collected over the course of years. Thousands and thousands of cycles were collected, and what he found was that 1 to 2% of cycles failed no matter what. So if you're not running a BI, right, and that was based on the modality that he used to test was BIs to see if BIs were passing or failing. What that paper shows is that basically for every 100 loads, 1 or 2 of those is failing. Even if the parameters are reading that the conditions internally are correct, sometimes there's an air pocket that isn't being detected by the machine. Sometimes there's a cold spot that the Bowie-Dick test didn't detect, and also the dials and gauges didn't detect as well. So the BI really is only the true measure of lethality, of the closest thing to proving sterility occurred within the chamber than anything. To be honest with you, the United States is pretty far ahead of Europe as far as making recommendations around BI use and pushing users, pushing the hospital healthcare facilities to utilize BIs for testing, weekly, preferably daily, with every implant load. On the steam side, for hydrogen peroxide, ST58 recommends, I think it's daily, preferably every cycle and every cycle type. And then for EO, it's every cycle. So the United States is a little bit further ahead on the standard sides of things when it comes to BIs and BI recommendation. And I think it just comes from the understanding of where we are and what BIs mean in the process.
Hey, Steve, you mentioned a couple of times now that the same bacteria, the Geobacillus stereothermophilus, is being used for both the steam and the hydrogen peroxide. And of course, like you mentioned earlier, the reason it makes such a good test for steam is that it's resistant to heat. What is it that also makes it a good test for resistance in a low temperature sterilizer that's using hydrogen peroxide?
Well, the spores that we use are typically resistant. There are different spores for, it's Geobacillus stereothermophilus when you're talking steam and hydrogen peroxide. For EO, it's a different spore. And the reason that the spores are different, partially because it's been identified that it's tough to kill in any condition. And so for steam and hydrogen peroxide, Geobacillus stereothermophilus is used. And it's used because it's just tough to kill in general. It's tough to kill. It's a really resistant spore in multiple conditions, whether you're changing the temperature conditions or whether you're exposing it to some type of gas sterilant that can potentially, kill it. We know that Geobacillus stereothermophilus is resistant in multiple types of conditions. When looking at creating BIs, we typically do all the testing. The testing is then submitted into the FDA. And so the FDA then validates that, yes, Geobacillus stereothermophilus is the right spore. We've identified that, it does withstand, certain different concentration levels of sterilant up to a certain point before it starts to die off. And that's when you start, and that's why we use Geobacillus stereothermophilus for those two modality types.
Well, so let's go back to the speed category for a second, because as Mike so eloquently coined the phrase BI wars going on, that seems to be, at least from the marketing side, in a customer's perspective, we see a lot of differentiating going on with it's faster. And even this week, I saw another one, coming out that say we're nearly instant read, What goes into, we don't have to talk, specifics about a particular time, but what goes in on a scientific basis to making these BIs read quicker? Is it some kind of magic to flip a switch and just to make those things, and say, hey, I'm dead? Or is it actually a different process altogether if you move from a 4-hour to 1 hour to 24 minutes?
We have BI elves at the factory that pump these things out. A little sprinkle of magic. I'm kidding.
Called it.
I noticed that comment before, that, the speed wars, and I think to understand how we got here, we need to really take a look at where we came from. So 30, 40 years ago, BIs were a little different. And for those of you guys listening, you guys probably remember the spore strips that you used, which was a manual process. You had to take, literally it was a strip, then you had to combine it and send it. And it took a very long time. It was labor intensive. The biggest breakthrough in BIs, 40 years ago, was a self-contained BI, where everything was contained within one vial, and that vial was activated, crushed, and incubated. So it really eliminated and streamlined that manual process. Then, flash forward into the early 90s, you had rapid BIs come forward. Actually, I believe it was the late 90s, early 90s, late 80s, early 90s when rapid technology came forward, and that's when we saw 3-hour, 1 hour time to result within the BI space, which moved everything light years ahead. Then you had flash forward a couple more years, 24-minute. Most recently, you've had 20-minute on the market. You got 1 hour, 3-hour, half hour. So I think what it comes down to, what happens in the lab, in our labs, what happens at 3M, is, we build on momentum. And so as we're in the space, learning, talking to our customers, learning from our customers, getting feedback on what they need, we optimize. And so hydrogen peroxide, when we launched the 4-hour BI, hydrogen peroxide came out at 4-hour. And then from our learnings of the 4-hour launch, we figured out how to make it faster. And so that 4-minute time to result came out fairly quickly. And that's just being able to, be agile, work within our scientists at 3M. We're able to turn on things pretty quickly just from learnings and breakthroughs that we've had. And a lot of it, comes from just some trial and error within the labs that occurs, just based on, years and years and years of BI experience labs. It kind of drives things forward. To put it in perspective, the speed dash, I think, is a good thing, to be quite honest with you. And the speed dash for the last couple of years has been great because it's been able to really move practice. And when I say move practice, here in the United States, every load monitoring is something that most facilities are striving towards. And the movement from 3 hours to 1 hour to 20 minutes to 24 minutes, and then, wherever we go next, it's really going to change the way that you guys out in the trenches perform your jobs, because it makes you that much better. It turns over results that much quicker, and it turns over instrument loads that much faster. It's gonna streamline your process and optimize you guys to be lean, mean, reprocessing machines.
Well, that's what we're all aiming for. Well, let me ask you about this. We've talked about the parts of the BI that have changed, but, it seems like when we're talking about the actual challenge pack of the BI, the part that you actually, put in right above the drain, it seems like that particular package hasn't really changed much regardless of, who you're using. And so I think there's some question that we know the bacteria gives up good solid resistance, but is the paper packing portion, say that 3 times fast, is that actually, providing a good representative challenge for the steam to actually get to the bacteria in the same way that it would be a challenge to get inside of a laparoscopic instrument or inside of a shaver or something like that?
That's a great question. Something that we've wrestled with, internally. The standards say it has to be representative. The biological indicator test pack has to be representative of an AMI 16 towel test pack. And the reason for that is, it's something, the AMI 16 towel test pack is something that we know is difficult, has been validated. It's something that's well known. Steam in general is pretty well known as a sterilant and its capabilities. The AMI 16 towel test pack, those paper test packs are meant to be representative of the 16 towel test pack. You're right, they haven't really changed too much. And the reason being is because, even though instruments have changed slightly, the challenge is still there. There is a built-in every cycle. So in the standard cycles, the kill happens, it occurs in 2 minutes. There's a built-in additional 2 minutes of overkill within the cycle to make sure that whatever's in that instrument, if they're exposed, and they can be accessed by the sterilant, that they can be killed. I think that the AMI 16 towel test pack and pre-assembled test packs with the paper are good indication, are still a good valid test to work off of and to release loads off of, to be quite honest with you.
So, Steve, since we have a BI expert on our hands, I do want to ask you one practical question that we get asked a lot in the field.
Sure.
In terms of disposing of those BI vials or ampules, obviously if you run a BI and it has turned negative for a kill, that's one thing. You have something, dead there. But if you're growing out of control, is there an issue, or are there directions, from the manufacturer to specify how that thing is supposed to be disposed of?
So it's a non-pathogenic spore. So even if it do have a control that grows out, right, which all controls should, that's the point, right? If you do have a control that grows out and you're looking to dispose of it, trash is fine. You can put it in the sharps bin. We even have some folks that, I think it's just human nature, that they want to overkill and make sure that nothing can happen. So they will sterilize any of the loose controls just to make sure that they're killing any of the spores in the BI. But it is non-pathogenic. So typical garbage is fine, but if you want to take that extra step because of the glass that's in the vial, you can dispose of them in the sharps containers.
All right, Steve. Well, as we're wrapping up the interview, I thought maybe we would, and this was coined in the early days of Beyond Clean, and now it's become kind of a running joke every time we want to talk about what's sort of next in development. But we're going to put on our future-looking goggles and ask you, what is next in the world of sterility assurance?
I think we're right on the edge of a technology boom in sterility assurance. I'm seeing one of the toughest things within, as I talk to SPDs all throughout the country, one of the toughest things I hear, and one of the biggest challenges is getting enough staff to be able to turn over the instrument loads, in the right amount of time. And so I think we're right on the cusp for some automation, to be quite honest with you. We're in the early stages of some instrument stringers, some automated instrument stringers, which could help aid the process of producing trays and getting them ready for to be sterilized. Tracking systems, all different types of digital integration, they're here. They're coming, and they're getting better. As the hospital becomes a smart hospital, as I like to say, and all the departments are becoming integrated through different types of electronic tracking systems. I think it's going to benefit the CSD and the SPDs throughout the country for the better. Instruments are getting better, and I think there will be advancements from a speed. We're seeing that now. As far as you guys referenced before, speed wars with biologicals. I also think with process, with the dual auto reader and a 24-minute standard result, with making the process that much simpler, I think there's going to be a drive towards simplicity. I think there's going to be a big technology push within the next 10 years. And I think the CSD of today will look slightly different than the CSD of tomorrow, and I think the CSD tomorrow will be much better for it, to be quite honest with you.
Well, anybody who listens to this show knows we're fans of big data and tracking systems and automation. So certainly to have a one warehouse for all that information and traceability, I think, is another big one that would make that so important. So, Steve, thank you for coming on the show and sharing your knowledge and expertise on biological indicators.
Thank you, guys. I had fun. It was a great time, and hopefully we can do it again sometime.
That was Steve Kubler, U.S. Marketing Manager of 3M's Device Reprocessing Division. We talked about biological indicators, and Mike, quite frankly, you impressed me with how quickly and how easily the bacterium name just rolled right off your tongue.
Well, thanks, Justin. I've been practicing that now for years. But seriously, this was a great interview. I really enjoyed. I learned a lot. It's interesting anytime you can take one of those things that, everybody sees, we are all familiar with, but you start asking the questions of why and start peeling back those layers of the things that we do every day and just kind of assume we know what's going on. And that's what's great about this show is we can do that here.
Yeah, and we had a pretty interesting panel discussion at the Isham Annual Conference, and maybe this is the kind of topic that we should have in this year's panel discussion when we decide to do another live event at Isham's Annual Conference. Maybe wait and stay tuned and see if that might be something that we end up going with. It's certainly worth consideration just because of the speed wars like we talked about.
Yeah, and by the way, I want it noted on everything that I coined the original phrase BI Speed Wars. So let's just keep that in mind as we move forward.
We'll certainly keep that in mind, Mike, and I think you should definitely get a patent on it. That's going to do it for this week's show. As a reminder, you can help support us by subscribing to Beyond Clean on iTunes or Stitcher, and now also on Google Play and Spotify. Simply search for Beyond Clean Podcast. We'd appreciate a rating and a review because your feedback is important to the show, and if you have any topics that you'd like us to cover on a future episode, or if you'd like to share a picture anonymously on our Instagram page, just send an email to info@beyondclean.net. On behalf of Hank, Mike, and myself, thank you for listening to another edition of Beyond Clean.